Richard Kelso, here we are at the brand new wind tunnel facility at the University of Adelaide, something that you've been very involved in the design of. You want to take us for a quick tour?
Sure.
If we can. All right, so tell us where we're going at the moment.
We're going to step into here and walk down.
I'm going to go through here.
Okay.
And if we look through there, you can see this is the area that testing will go on.
Yeah, this is what we call the contraction. This is where the cross-sectional area of the tunnel is reduced and that accelerates the flow and improves its flow quality. From here, the flow travels in this direction. We currently have a model showing how a model might be placed. Is not properly installed at this stage, but it's certainly shows a model just about the right size for this tunnel. Right. We can test quite large models in this tunnel.
Now Richard, around here, if we can, this is a big screen, which from a distance it looks like a big piece of aluminium, but it's actually a screen.
It's actually stainless steel, woven stainless steel.
Right. So what's its purpose?
It's to smooth out the flow. It actually produces very fine turbulence, which helps to break up the larger turbulence. But the net effect is that it produces a very even velocity across the tunnel. We want the velocity to be the same absolutely everywhere across the tunnel, and we do it using screens and the contraction.
Now, as we make our way out of this section of the wind tunnel, we go down here. We can see that the tunnel itself goes right around here, right round through there, and this is the engine room. This is the fans here.
Yes, there are 6 135 kilowatt fans from basically the mining industry, and they push the airflow around the wind tunnel up to 300 cubic metres of air per second. It produces up to 190 kilometres an hour in the fast working section that we were just looking at, and about 120 in a slower working section across the other side of the tunnel.
So the air is moving through in an anti-clockwise direction,
yes,
which leads us to another section over here, which is a large section. Obviously the wind has to do a right angle turn, and there's baffles there to help it do that. Yes. And we have another section here where you can do further testing.
That's right. I should just comment that normally we won't be able to see the baffles or turning vanes, but we have a wall of what are in fact sections of downpipe that are used to straighten the flow so that we get a very even straight flow coming down this section. Now down this tunnel section here we actually have a turntable down at the end where a bicycle is currently sitting, so we can turn the model to any angle. We can test bicycles with riders on them or individual components of bicycles. We can put cityscapes and test buildings. We can measure the pressure on building surfaces, on windows for example, so that they can be designed so they don't fall out. We can test the loads on adjoining buildings, so when you erect a new building you don't disturb the other buildings. And we can test suspension bridges, any kind of large model in here.
Yeah, just to put it into perspective, Richard, if we can, just how significant is this wind tunnel for South Australia?
Well, there's nothing else like it in South Australia. Currently all the work of this scale has to go interstate. There are other wind tunnels that are a bit smaller in other states, but this tunnel is going to reduce the cost and improve the facilities available to South Australia, to South Australia's business. We'll be making this available for defence, for sports, for building industry, for wind energy industry. It'll be available for South Australian business to improve its business in the future.